In this video we're going to look at integrating simple expressions. So integration is the reverse process of differentiation, and that makes it relatively easy to integrate simple expressions such as this one. Now we need to know about the notation that we're using here. So we've got this kind of elongated S shape, which is the symbol we use for integration. And then here we've got the term that we're going to integrate. And at the end here we have the variable which we're integrating with respect to. So in this case we are integrating with respect to x. Now that's important for expressions where we might have more than one variable or more than one letter. So to integrate this, I'm going to do the reverse of differentiation. So in differentiation I multiply by the power and then I reduce the power by 1. So if I work through this backwards, I'm going to increase the power by 1 and then I'm going to divide through by the new power. So that will tell me that 3x to the 4 will integrate to 3/5 of x to the 5. Now when we're integrating like this, we put plus c on the end, where c would be a constant. And we put this in because any constant that would be differentiated would just disappear. So we don't know whether or not this expression, this term, actually contained a constant. So we just put plus c on the end just in case. So the second one, I'm going to go through much the same process. I'm going to integrate term by term. So the first term, I'm going to increase the power by 1, so it's going to go from 2/3 to 5/3. I'm going to divide through by the new one. So if I write this as a fraction, it's going to be 4 times 3/5. And I'm going to integrate the next term, so x raised to the power by 1, divide through by the new power, and then put plus c on the end. And now I can simplify that first term to 12/5. And I have fully integrated my function. Now this last example, we're going to see why it's important that we specify the variable we're going to integrate. Because we've got an a and we've got an x here. And it's the x which we're going to integrate with respect to in this case. Now that means the a is treated like any constant. So 4a to the x squared, or should I say 4ax squared, I'm going to raise the power by 1, and then I'm going to divide through by the new power, and I'm going to do the same here. So x squared becomes x cubed, and then it's 3/2 x cubed, and then I put plus c on the end. And then I could, because these are both x cubed, decide to simplify this further. So I could write it as 8a/6 x cubed added to 9/6 x cubed plus c, which I could then choose to write as 8a plus 9/6